So good afternoon, everyone. First of all, thank you so much for this opportunity. Start with my self-introduction. My name is Alwin Poulose. Currently, I'm working as a researcher in Kembuk National University, Daegu, South Korea, where Bharat sir was doing postdoc. So today, our discussion topic is about intention prediction through human activity recognition with the indoor localization. So during the presentation time, I discuss the following topic. We start with a small introduction about our research area, and for the intention prediction, we consider activity recognition, indoor localization, and combine this both information together, predict the user behavior or user understanding. And also next is our intention prediction, how to identify the user intention or prediction using location information and their activity information. And finally, I conclude my presentation with some experiment result and a way forward, like a future work what we plan to do next few years. So when we start with our human intention prediction systems, like our system, we need to develop a system that ability of an AI device to predict human intention from behavior. So the system consists of human activity recognition in indoor and outdoor environment, but this research mainly focus on indoor environment, indoor application. During our experiment and discussion, we consider only indoor, outdoor. Most probably outdoor environment well established localization technology by using our global positioning system GPS and using pervasive or non-instructive and affordable technologies for our intention prediction. And the major application of our human intention prediction are healthcare application, smart homes, security, and etc. So basically our main objective or goal of this research to understand a user habit and predict their next activity or emotion. So when we start with our goal using data from wearable device and sensors. So to start with our problem statement, we consider some type of special sensors like IMU sensor or stress sensor or some type of depth-wise cameras. And using that sensor data, we continuously collect the data from each sensor and monitor the user activities or behavior. So from a series of activity in this research, we consider around 7 activities for our research. In the next slide, we can discuss like what type of activities and what type of experiment scenario we used for our research. And the other thing is that the experiment is a known environment like inside a room scenario we consider for our research. So we start with our goal, like first planning about our research, what type of work we have to do for developing our human intention prediction system. So the first stage is activity recognition, identify the user activities. The next is a localization. So identify the user position in indoor scenarios. That is our second problem statement. And next is combine this both information or both data and develop a general model. So make a model or a prototype. That's prototype aim is to predict the user intention or predict the user emotions using activity localization. And for the further research also we consider user facial expressions also. And using the general model we develop a system like prediction system, and the recent research is reinforcement learning. So using reinforcement learning technique improve the performance of the prediction system. So when we plan our research, our behavior in this research scenario, we divided into like activities and location. Also, we consider the current time information. So for the activity estimation, we use the accelerometer sensor, gyroscope sensor, and also others in the sense we in this scenario we use the stress sensor. So the data from these sensors we used for activity classification. And for the localization, our objective is only in indoor scenario, so we exclude the GPS technology in this research. We don't consider the global positioning system. Only indoor, and in indoor localization, we consider different types of technologies, algorithms. We proposed our own method to identify the user position. So here is our proposed intention prediction system. So which consists of like action recognition system, localization system, and data aggregation. So in our event, we classify like action, location, time information, the time information from our clock, and we formulate a huge data set like human behavior data set, and we develop a intention prediction system. So the output of intention prediction system is wants to have lunch or wants to have television, sorry, wants to watch television or wants to sleep. So this type of some type of intention we predict by analyzing the activity and the user location. So when we start with the activity recognition, we discuss about the basic background research in the human activity recognition like HAR. So predicting human activities from raw sensor data collected over time. So we have a smartwatch or our smartphone or Fitbit or like band or any type of sensors like this type of device. They have the IMU sensor, inertial memory unit. So using that IMU sensor, we have the accelerometer and gyroscope data, and we collect the data and for each activity, and our recognition system classify what type of activity the user is doing. So when we consider the application of human activity, the major application is healthcare, and next is abnormal activity detection, smart environment, indoor navigation, security and surveillance, and research and UAVs. So these are the major applications related to human activity recognition. And when we consider the approaches related to HAR, they divided into three types like vision based, radio frequency based, wearable sensor based. So when we consider vision based approach like camera mounted in the environment, so these days like the webcam or the CCTVs are available everywhere in the public places, so we can utilize that features for our activity recognition. But the major issue with the vision based approach is the privacy. So we have to develop a algorithm to hide the user privacy or hide the face of the user, or this type of research we have to add additionally we have to implement. And also the cameras is like high cost and complexity, and processing videos are very high complexity as compared to sensor data. So next is radio frequency based, RFID based. So it's device free passing sensing, and but it's like the major disadvantage related to RFID is like location dependence and also environmental interference, like the channel condition also affect, or non-line of sight condition between the transmitter and receiver also affect the performance of RFID based system. So the next is wearable sensor based technology. These are the most popular, and these sensors are very common in these days like our smartphone or our smartwatch or our Fitbit, the band devices. So location independence and unobtrusiveness and also low installation cost, so it's very cheap as compared to other two approaches. In our research we consider the vision based approach and also wearable sensor based approaches. So user activities. So mainly the user activities are divided into two categories like basic activities and compound activities. So in the basic activities like the motion like walking, walking upstairs, walking downstairs, falling, jogging, these are the motion activities inside the basic activities, and also stationary activities like standing, sitting, lying. So in our research we consider basic activities like standing, sitting, lying, walking, and also some type of uh, activities like push up, sit up, this type of scenarios we also consider. And in the compound activities like a normal activity scenario, normal our daily life like doing laundry or making coffee, studying, bathing, cooking, watching TV, using phone or reading book, or this type of etc activities. So when we consider compound activities, the complexity of system is very high as compared to basic activities. So it depends on our application or where do we need to implement our system. Based on that we decide which activities we need to implement or we need to follow. So when we consider the conventional learning approaches, so our basic system has the sensors like smartphone or the IMU sensor mounted in our shoe or smartwatch or smart glass. So any of these sensors and connected with our server system using Wi-Fi or Bluetooth, or also sound, also acoustic signal also we can consider, or the location information. And we do the feature extraction technique or model training. Then like in the model training, first we extract the features like various mean, minimum, range or maximum in the or in the time domain or in the frequency domain. And our model consists of like k nearest neighbor or naive basis or neural network. Train the model and identify the user activities, classify the user activities. So limitation of conventional methods. So when we start with our conventional activity organization, it's require handcrafted feature generation, and time domain and frequency domain statics are generated for each window. So there is no magic formula that's requiring expertise and experience, and it's very difficult to generalize the model. Accuracy drop for user not included in training dataset. So our trained dataset, we have to consider maximum number of users, different types of category like a gender difference and also the height difference, and maximum number of users we need to consider for training the model. And also sensor displacement. In that scenario, uh, we have to collect the data in different position of sensor, like mounted in our wrist or wrist or in the ankle, or depend on the IMU sensor, the position also affect the performance of the system. And not optimized for low resource consumption like the mobile devices or wearable smart devices. To overcome this limitation for the conventional method, we have the solution like data augmentation, increase the number of data size, or leverage advance in artificial intelligence, like introduce the deep learning ideas or deep learning technologies to our system. So next is our deep learning method. So similar, the same raw data we collect from our sensors and directly apply to the our deep learning models like CNN model or deep neural network model or RNN or LSTM model. And this model has the capability to classify the user activities like upstairs or running, riding bike or having coffee or watching TV. So it is about classification by using deep learning is the current research hot topic. So we tested our result with some dataset like UCI dataset is the publicly available raw dataset, and UCI also provide a feature dataset, and our ISPL dataset like our own dataset, we collected some data using our smartphone and also feature. So we tested with the different deep learning models like CNN, LSTM and hybrid model, CNN, LSTM model, SVM, KNN and GNB model. So our CNN LSTM model has the best performance as compared to other cases, like maintain the performance in all scenarios like only raw data or feature data. In that four scenarios, the hybrid system shows better performance as compared to other models. So here is our proposed HAR system using IMU and stress sensor data. So here we used three IMU sensors. One is in the wrist, waist, and ankle, and also we use the stress sensor. We have two stress sensors in our knee. We attached our knee, and we collected the data, and we used our deep learning model to classify the seven activities like sitting, standing, lying, walking, push up, dancing. Dancing also we considered, sit up and running and jumping. It's just like a scenario based on how we can collect our data. So depends on your application, you can decide which type of activity you can use for your research or your application. So previously we use the sensor based approach. So next is human activity recognition system using camera. So camera major concern is the privacy. So if privacy is not a big issue for our application, we use the smartphone camera. We create our HAR dataset for different activities, and first we identify the human body detection using YOLO algorithm. So first we identify the human body and crop the image, like remove the background, and cropping and resizing our next steps. And for our data, there is some type of irrelevant data or some other object also identified. So data cleaning and removal of relevant data. Then some type of data segregation we do, and our segregated data we use to the deep learning model. So in this research we consider different types of deep learning architecture, like for classification performance like CNN, ResNet, AlexNet, exception model, and finally we classify our user activities like 7 categories. So here is our first HAR using IMU sensor. So here the user holds the IMU sensor in his hand and just walking. So we also identify the user location. So the localization scenario we will discuss next discussion. So here the user is walking. So here our server side we identify what type of activities. Like in this scenario we consider only 3 activities: walking, standing, and also sitting. This one is our basic system just using IMU sensor, and next is we used our stress sensor, and the user is holding this stress sensor and also the IMU sensor together, and the user is walking. So this also very basic system by considering standing, and also there is a small delay in the server side to get the model to understand, so there is a delay, and sometimes the performance is not very accurate. They are fluctuating like between the activity like sitting, standing. When the sensor is stabilized, the performance is very good, and when the transition also we have some problems. So we consider like only 3 activities in this scenario, and our also we updated our system with comparing IMU sensor, combining IMU sensor and stress sensor together, and here is our advanced version of our system. So here we consider almost 7 activities, like sometimes misclassification is there, the performance, and also there is some delay from the sensor to the server side, and also lying. Next we consider there is some misclassification between sitting and sit up, and running classification is also okay, and jumping is also okay. It's like a unique activities, but when we consider like similar type of activities based on the sensor reading, there is a classification error. So also we consider the sit up and push up also. This like just randomly we selected some type of activities, depends on the user scenario, and this is our final system. We replaced all sensors with our smartphone, and we developed our system using, like, we developed a mobile application, and we have in our phone we can identify the activities, and also we consider accelerometer, gyroscope, and linear acceleration data together, and we created a office indoor environment scenario like a normal a student would normally do. So based on that, like using laptop, this type of scenarios we consider, and also drinking tea, taking coffee, these type of scenarios also we consider and identify the user activity and location. So these are our human activity recognition system, like the research. So the next section is our indoor localization. So we start with our location, identify our user position. So exactly where we are, the exact user position, that is the idea behind this research. So when we start with the indoor localization, it's called refer to determine where an entity is located. So also positioning, locating, or position tracking. 3 target areas: indoor, outdoor, and ubiquitous. So in that case, indoor and outdoor together. But in this research, we focus on only on indoors. So outdoor localization is well established, and the satellite positioning, we already know GPS is well established everywhere. And the major problem related with the outdoor localization, it requires clear view of sky, hence not available for indoors. So when we consider the GPS inside a room, the penetrating characteristic of GPS is very difficult. So the accuracy of the GPS is not reasonable for our indoor application. So in that scenario, we consider a different research technology or research idea for our indoor localization. So GPS problems, when we consider the accuracy is 6 to 12 meter, this is not a good accuracy for our real-time implementation for tracking or navigation, and the reception of the GPS signal is not strong inside a building. Satellite signals are easily blocked by roofs and trees. That is also another issue. And privacy and tracking issues related to GPS technology, and also interference, jamming, and spoofing. So these type of challenges we have when we use GPS signals inside a room. So when we consider indoor localization, so why we need to use indoor localization, identify the user position. So the major idea behind this is like the indoor environments became increasingly complex, and also like monitoring people flows or optimizing steps and product placement in a supermarket, or identifying the bottlenecks of in environments, or in the airport or supermarket or any indoor environment, we have to identify the user position. So the major scenarios like bus view, like in inside a tunnel, or also inside a parking area. So we need to identify the vehicle, and also navigation inside building or inside a tunnel, this type of scenarios, and child tracking. These are very simple application. So main challenges when we consider for indoor localization is layout of environments are very complex, and the mixture of open and confined areas, most signals subject to refraction and attenuation, and also the number of people inside a room. When we consider large people, or the varying crowd densities, the humans absorbs and influence most signals that are used in positioning, and accuracy cost trade-off. So best accuracy requires expensive investment, and also maintenance cost. So to maintain the localization system, we need to invest a lot of money for that, and replacing the device or installing the sensors also very expensive. So when we consider the application of indoor localization, these are the major applications like manufacturing, public transportation, and also logistics, army, military identify the soldier or tracking the soldier, also agriculture, and research and UAVs. So we start with our localization technologies, the idea behind localization. So majorly indoor position technologies divided into building independent and building dependent. So in building independent, we use the image based technologies and dead rocking, and building dependent, we have building infrastructure utilized, dedicated infrastructure required. So in the building infrastructure utilized, we use the Wi-Fi RSSI based technology, or the cellular, our using our smartphone signal, the cellular signal, and also Bluetooth technology. And in the dedicated infrastructure required, we use the RFID, UWB, or infrared, ultrasonic, Zigbee, visible light communication, or acoustic signal. So in the red boxes, these are the research we considered for our purpose and our application. So in the next slide, I can discuss more details about the idea and the algorithm used for the this type of indoor localization technologies. So when we use the localization techniques, these are the existing algorithms used for identifying the user position. So basically the localization techniques divided into range based and range free. So range based triangulation and range free fingerprinting and vision analysis. So the red mark boxes are we used for our research based on our application and our purpose. But generally, like these are the existing localization techniques to identify the user position. So when we discuss with our research, we consider three localization technologies. Like first we start with the IMU sensor based localization, and also next Wi-Fi RSSI based localization, then camera based localization. So these are the three localization technologies we used for our research. So when we start with the IMU sensor based localization, here is our proposed IMU sensor based localization. Here we used three sensors called accelerometer, magnetometer, gyroscope. So from the accelerometer, first we identify the pitch and roll values, and from the pitch we identify the user step and step length, and also from the magnetometer we identify the heading, and also from the gyroscope data we identify the heading, and using a Kalman filter we combine the both heading to improve the performance of the system, and using heading information and step length information we identify the user position. So this is the basic algorithm used for localization using IMU sensor. So here is the detailed explanation of step length estimation. So first identify the steps or step detection algorithm. Then from this step detection we identify the step length using some type of algorithm. And also heading, also we use the sensor fusion to combine the both heading information from gyroscope sensor and magnetometer sensor and identify the user heading. And to analyze our system, we consider three experiment scenario in our laboratory, like a rectangular motion, straight line motion, and a circular motion. And from the these are the localization result from our experiment. So from here we also compare with a conventional approach with our proposed approach. So in the conventional approach we didn't use all type of uh, sensors, and we didn't use the pitch based step detection, and some major difference we have as compared to conventional approaches. And by this result analyzing, our proposed approach shows very accurate result as compared to conventional, and the result are more closer with our ground truth values. So next is Wi-Fi RSSI based localization. So previously we discussed IMU sensor based localization, and now we consider Wi-Fi RSSI data from the access point, Wi-Fi access point. So first we collect the RSSI data, and we have our experiment room, and for this research we consider three access point, and we create a Wi-Fi RSSI heat map. So this heat map we feed into our deep learning model, and we also use the hybrid deep learning model like CNN LSTM model, and we train the model, and also we tested with our offline, and finally we estimate the user position. So the idea behind is like each location the characteristics of RSSI heat map is different. So that is our key idea to identify the user position. So the last technology we used is camera based localization. So here is our previously IMU based system, and also we combined with our camera based system. So in camera based system we consider ORB SLAM algorithm, very most common and popular camera based localization algorithm, and also we consider UCOSLAM, and we implemented a sensor fusion algorithm and identify the user position from IME sensor and camera based together using our sensor fusion, and we combined the both positions together to improve the performance of the system. And I think the mathematical, we created a mathematical model how to combine, and we have so many challenges for the combining both position values. So we created a state variable and state model, and by using this model we analyze the user, we estimate the user position. Our system achieved 19 centimeter localization accuracy. So here is our demonstration. So first we start with our basic system, like a localization using just IMU sensor. We hold the IMU sensor in our hand, and we just user is just moving in our experiment area in our laboratory and identify the track the user position. But the major problem with this technology is like it's very difficult to identify or correctly estimate the position due to the floor map. So next we consider a more extended version of our experiment. Also we combined with our activity recognition system, and we created a floor map, and we did our experiment. We identify the user positions like in a classroom scenario. So here is our floor map based localization. Next is like a Wi-Fi RSSI based system, but this system is not a robust system for real-time application due to the characteristics of Wi-Fi RSSI signal. The RSSI signals are not stable for real-time implementation, and it's very difficult to identify the user position accurately when we used only RSSI data, and the system has so much delay due to the RSSI data processing. So next is our camera based system. So localization using camera, here using our smartphone camera we identify the camera pose. So from the camera pose we identify the user position. So the user is holding the camera in his hand and moving around the experiment area. But the major challenge with camera based technology is the processing delay. So if we process the video signal, video data is very high, the complexity is very high, and the delay is very high. So in that scenario we have to record a video in a low quality video, or if we use a 4K video, the system takes so much time to estimate the camera pose. So next also we did a analysis on multi-user activity recognition. So we consider two users to make this, to extend our system to make it more robust. So but here also we have some challenges, like each user characteristic is different. So the user one, the way of walking is different, totally different from user 2. So that is the major problem, and the step length is also different. That's why the trajectory pattern is totally looks different. Only the pattern is following same, but the user step is different. But still the system needs so much improvement to make it as a general system. So in this case, we need to enhance our data set, and also we need to improve our prediction system. We have to also use our advanced version of higher deep learning architectures. So here when we do the multiple of times the same experiment, there is a sensor error, the sensor there is a gyroscope drift error. So still it's very difficult to solve that challenge when we continuously doing the same experiment. So currently we also working on to this error, how to solve this problem. So in the conclusion, like in this presentation, our objective is to identify the human intention. So for that we implemented the activity recognition system. So recognize the actions and goals of one or more users from a series of observation, and implemented deep learning and machine learning technique and achieved accuracy of 95.09%. And in the localization, we providing a precise and accurate position of the user in their environment while performing a specific action. And our overall localization error is 50 centimeter, like 0.5 meter. Like a hybrid system has higher performance, but in a real time the implementation is very hard, and also complexity of the system is very hard. And the human behavior understanding and intention. So our final goal is to combine this both information and identify the human intention. So combine activities with the user location and time to learn their behavior. So be able to predict their intention based on this learned behavior. So way forward, our next stage is to uh, make a generalized model or improve the performance of the system. So in that scenario, we also consider user emotions. So previously we considered only user position, user trajectories, user activities, and also we added facial emotion recognition. So we use a camera and capture the facial expression. From the facial expression, or facial emotions, we can identify the intention of the system. And finally we combine the both system using a fusion system, and we develop a human intention prediction system to predict the human behavior using the location information, and also activity recognition, and also emotion recognition. From these all information, our final goal is to predict the user behavior. And also in the facial emotion recognition part, we did some research. So we did the data collection for 7 categories of emotions, like a user is try to express the emotions in different scenario. So in that case, we used a camera in front of the user, and we use a smartphone, and we played some videos uh, related to the emotions. So the user tried to simulate the emotions, not the exactly matching with our real situation, but still our system gives almost around more than 90% accuracy by using our data set. So we collected around 9,000 data sets from 9 people, and we tested within the real time. So real time, the system performance is not very accurate, and sometimes the system is not identifying the exact emotions. Sometimes misclassification is there, but the very natural emotions like happy or surprise, this type of emotions the system can easily classify. But some type of emotions like between two emotions, it is very difficult to classify, or the error is very high. So we need to improve the performance of that system. So next is related to our this research area, like a eHealth proposal. So we try to make a system. That system gives information like a physical health, emotional health and mental health. So we have a user interface, and the user interface notify the user like our emotions. So using this system eHealth, we can monitor our health and identify if the user is in a sad condition or in a depression. The system notify or give warning, and the user can easily overcome the situation. So also the next major application using our system is soldier tracking. So using our localization algorithm and also activity recognition algorithm, using some sensors, we identify the soldier location and also soldier activities like sit or throw grenade or like shooting or walk or change weapon. So this type of scenario also we can consider for our further studies, like for a soldier tracking. And also our emotion recognition system we implemented in the driver monitoring system. So we consider different types of emotions, and in a driver scenario, like a driver is driving the car and identify the activities. So this system we can use for the autonomous driving system, and the system gives the warning to the user like to focus on the driving, or we can avoid the road accident scenarios or situation. Here also the system identify different type of categories like smoking, if the user is smoking, or using cell phone. So these are the major reasons for the accident occurrence. So our driver monitoring system gives the warning to avoid this type of scenarios. And also if the user is not focusing on the driving or like deviating their focus, the system gives the warning. So this type of application also possible using our activity recognition and facial emotion recognition system. So thank you for your attention.